Professional duties.
I hated having it set up.
Okay.
Yeah, I sat with you, Kara. I sat with you and Kara. And then it was Noella, Molly.
All right.
First depressing. Front is depressing.
Actually,
Poor babe.
Check your answers. Check. There's 1, 2, 3. Now this morning I did it quickly off the top of my head, so I screwed up, and that's why it looks messy. 42 over 20 CA, 235 over 92 U, 4 over 2 HE. I'm just showing you the answers. I'll go over a few of them slowly in a minute. So there's 1, 2, 3. There's 4, 5, 6. This is 4 over 2 HE, 3 over 1 H. I think we did that together. Yes, in class? I think so. 1 over 0 N. That's 6. This one throws kids off sometimes, but it's a neutron because that's the only thing. There's no such thing as an element with a 0 atomic number. So when you realize this is 15 here, and that already has a 15, this has to be a 0. The only thing that it could be is a neutron. It's the only particle with a mass of 1 and no charge. That one's kind of hard. 7, 8, 9. I know 9 was hard. We'll go through that. And I'm going to probably get rid of this and do it by hand on the board and just make it bigger and easier to see. But, 6 over 3 Li, 37 over 18 AR, 235 over 92 U. Alright, so there's 7, 8, 9. So right now you just fix whatever, if you made a mistake, fix it, and then we'll go over some of these afterwards. And then number 10, 241 over 94 PU.
Why are you laughing, boy?
It's a bright sweatshirt you got.
It's bad placement
Nice.
for the
You
word.
got
though.
that? Have you lost?
Once.
Just once.
Yeah.
Good job. Keep it up.
Yeah. I actually got MVP for like the heavyweights from like 170 to like 200. I got the MVP
On this, in this tournament?
yeah, from like based off of like other coaches.
That's
Throughout the
cool.
entire
So they
tournament.
vote on that.
No.
What's that?
They vote on that.
No.
Yeah.
That's
No,
cool.
for MVP for making the MVP. Yeah.
Cool.
lying to him. You didn't get MVP for
Bet.
Alright. Let's go over the ones you want me to. Does anybody have any you want me to go over? I have certain ones I'll just go over, but any of them that you got wrong, you're not sure where it came from.
Can we go over 9?
Yep.
Top number.
We will go over 9. Any others? Okay. Turn the lights on, please. Alright, now, first thing I want to do before I go over this with you, I want you to circle the ones that are artificial transmutation. Circle the ones that are artificial transmutation. What that means is the ones that humans must make happen. There are some on here that are natural transmutation, but I want you to circle the ones that are artificial. And if you get them wrong, whatever.
That scientist made.
Well, yeah, that scientist created. Yeah, there's let's see, there's 1, 2, 3, 4, 5, 6 of them on here that are artificial. And what that means is a scientist takes one particle, speeds it up in a particle accelerator, right? Will knows where that is. I know Will knows the name of it. And he slams the particle into the nucleus of another one. What's the name of it? Well, yeah, the Hadron Collider, right?
It's in Sweden, right?
Switzerland.
They're practically the same thing.
Nope.
They both start with SW.
Does that mean Will's?
Yeah, they do.
Oh.
What?
Nothing.
Don't even start.
Don't
If you're from Switzerland, are you Switzerlish?
You're Swiss.
Yeah.
Oh, you Swiss?
I never heard anybody say Swiss. Like,
Really?
Yeah. I
Really?
mean, like
Swiss
cheese, dude.
Switzerlish. Switzerlish. Switzerland.
Switzerland.
Sounds like a candy.
Switzerland.
Sounds like a candy.
You think of Swedish, it's like.
Come on, circle.
Indian.
Unfamiliar.
Jake, Switzerlandia.
Let me, alright, listen, focus. So, let me say it again. Artificial is where a scientist takes one particle and smashes it into another. So if you look at the sheet, what's the trick here? What are you looking for?
Another one adding on to another.
Two reactants.
There has to be two particles colliding. Well, yeah, there has to be two particles on the left side primarily. So the left side, what do we call it?
Reactant.
Reactants. Okay. Now reactants products, that's more of a chemical thing than nuclear, but it still works. So your reactant side, the left side, we're looking at numbers 4, 5, 6, 7, 9, and 10. 4, 5, 6, 7, 9, 10. Those are artificial because someone is making that happen. All right, let me use number 5 as an example. Okay, everybody look at number 5. What particle is being smashed into lithium? Neutron. That's a neutron. Okay, neutrons don't just naturally fly through the air, smashing into the nucleus of atoms. Okay, that doesn't happen. That has to be done in a controlled setting. So I'm trying to just make it a little obvious that obviously that one is an example of artificial because there's a neutron involved in lithium. That doesn't just occur just on the side of the road. Okay. All right, but number 1 can. Potassium in some rock will emit beta particles naturally. I showed you the disc in the back, and it was naturally giving off radiation. I couldn't get it to connect, but you could hear the beeping. Number 2, again, Pu, plutonium, is releasing alpha particles naturally. There's no other particle interacting with it. Uranium-235 gives off alpha radiation naturally. Okay, so if you see one element on the left side, that's natural. But I prefer you not to memorize 1 means natural, 2 means artificial. I mean, if you can, great. But if you just memorize, you're not really learning a whole lot. So I'm trying to explain that using this homework here. Number 9 is called nuclear fission. Have you heard of it?
Yeah.
Okay, we do that in nuclear power plants. That's how we create electricity from nuclear power. We'll get that in our notes, I guess, tomorrow. What about number 4? Does anyone know what that is? It's a special reaction. It's really hard to do on Earth. In fact, we can't do complete this. We can only do partial. Number 4.
Oh,
Doesn't that happen like on the sun?
that's on the sun, yeah.
Yep.
Yeah, it's.
What's that called? Fusion.
Okay.
Nuclear fusion, yeah. The sun is taking hydrogen atoms and fusing them and making helium atoms.
Why can't we do that on Earth?
Yeah,
It's too hot. It's just
Wait.
too hot.
You need heat that we can't produce.
Wait,
Energy.
too hot on Earth?
Energy that we
Yes.
can't produce.
There's too much energy in too hot is a very simple way to answer that question.
Isn't the
There's too
sun
much-
a lot hotter?
Huh? But that's on the sun. Try doing that on Earth. Kind of hard. Put the sun on Earth, what would it do?
We would melt.
Yeah.
Everything would vaporize. I mean, the sun's
No.
ridiculously big, yes, Earth, but
We would
it's very difficult because of the energy involved.
You'd melt.
Plus,
Then you-
the 2 nuclei of hydrogen must break apart and then fuse together, listen up, to make helium. That is really, really difficult to do. Completely. You can do it incomplete fusion. I'll talk more about fission and fusion in the next couple of days, but fusion's very hard. But if we could actually successfully complete fusion in a safe way,
Balloons for everyone.
it would, what?
Balloons for everyone.
Well, no, energy for
Oh.
everyone. There would be unlimited, I forget the statistic, but it's like, if we were able to just use, it's like less than a fraction of a percent of the sun's energy, we would have enough energy for the entire existence of the universe. Like it's such a massive amount of energy that we could use, and there's no pollution, there's no fossil fuels needed. It's like fusion is the answer if we could ever get it to work perfectly, but it's very hard.
So I'm just gonna bring us back to like if the sun was on Earth.
I mean, it can't be, but
I know, like if it was, like
Yeah.
would we like automatically vaporize or just
Mhm.
melt first and then vaporize?
some things would melt, some things would vaporize. I don't
that were plasma size.
Yeah, then plasma would happen. Yeah.
Did you know that there's a helium shortage in the United States?
No.
There's a what?
There's a helium shortage.
All right.
Oh,
Darn.
Oh
Can't make my voice
no.
line.
Let's go over 9.
Why don't you shoot for
Here we go, number 9. Alright, so the answer is U235 over 92, and here's why. This is BA, this is KR,
It says 238 on ours.
no, but this is 235. 238 is the one on the chart, that's not the one we're dealing with here.
You were a 9, not 10.
We're a 9. Yeah,
Thanks, Quinn.
okay.
Gotcha.
142 over 56, and 91 over 36 plus 3 neutrons. All right, so this is the one that maybe Will, because he asked somebody else or anybody who got this wrong, made a mistake. This one is here. These two numbers add up to 233. This 3 1 over 0n essentially means this. You have 3 neutrons. So that's 1 plus 1 plus 1, so that's 3. So the top number over on the right is 236, so the top number on the left needs to be 236. 1 plus 235 is 236. And then the bottom 92 is because these two add up to 92. Yes, sir.
Could you just do like 3 times the one on the top
Yep.
instead of doing
Same thing.
that thing?
Uh-huh.
Alright.
Same example. Okay, so that's number 9. Let's go over number 7. 9 over 4 BE, and it's hit with a proton. This is a proton, and the missing element there is lithium, but let's just explain it as far as why. So 9 plus 1 is 10, so this must be a 6, because 6 plus 4 is 10. Remember, this is like an equal signs, 10 and 10. 4 plus 1 is 5, 3 plus 2 is 5. Now, which number do we look up? Right, the 3, because that's the atomic number. That's the identity of the element. The mass can change. Those are isotopes. Well, that's all that. So that's those two. We did that one together. Any other questions? We're good with this? The next few days, I'll be giving you warm-ups that are kind of like this. Questions on the Regents exam say, which of the following is artificial transmutation? So you have to pick it out. Which of the following is natural decay? You'll have to pick it out. Some of them are fill in the blank like this. And the 4 choices will have options for fill in the blank. All right. Put that away. Here's your test bag. Quiz, test, whatever you want to call it. Oh, I don't need to record this anymore.